you through how to like upload, download files, input, output, and do some data manipulation or things like that. All right, so let's just get started and I'll share my screen right now. Share it. Okay. Can y'all see my slide?
Yes.
Okay. So my name is Huang, and I'm now second year MP student. Also, work as a stat lab tutor. And today I'm going to introduce you to SAS. So, okay. So SAS stands for Statistical Analysis System, and it's developed by SAS Institute. So it's not an open source, it's proprietary. And it's useful for data management, modeling, analysis, visualization, and so many other functions. It's widely used in finance, insurance company, education, and healthcare industry, especially in government department or something. They use this a lot, potentially because you do have a um, support team for you because this is a company and they do have support team for you to solve those problems. And also, if you're dealing with some confidential data, you want them to be protected and not using probably some open package from open source software. So in order to access SAS, there are two ways to do so. First one, you can install SAS. This is not necessary, but if you're dealing with a really like huge file or something, maybe you want to run it on your computer, then um, you have to download it from WashU software licensing. And this is where you can download it and you can use this link, student use only, also with these instructions here. But one thing to notice is that if you're using a Mac, you're not able to do so because SAS is only for Windows. So you have to install Windows or get a Windows laptop for it. But fortunately, we do have this cloud version of SAS Studio called SAS On Demand for academics. So you just have to sign up with your WashU email, and all your codes and your files are going to be stored on the cloud server, just like Google Drive or something like that. But there is a storage limitation, is 5 GB per account. So if you're doing like say a huge project, maybe this is not uh, feasible. But if you're just dealing with say enhanced data set for like 1 cycle, 2 cycle, you're totally fine with that. Okay, so you just have to click this link or just use Google search to search SAS on demand for academics. And you can hit access and you'll see this page. So if you don't have an account yet, you can click this to create your SAS file, profile, and then just type in your WashU email and the institution like Washington University, and you'll be able to create an account. And then you hit this sign in, you'll see the web page. So let me sign out real quick. All right, so after you sign in, you should see your account is right here, and then you can hit launch. And it will sign you into the SAS Studio. And also for the local version, if you install SAS on your computer, you'll see SAS and you'll see SAS Studio. So if you're using SAS Studio, the interface is totally the same as we're using SAS on demand for academics today. So it's just like R and R Studio. So Studio is giving you more interactive interface to you to use easily. Yeah. All right, so this is the SAS Studio interface right here. So you'll see on the left-hand side, you'll see this server files and folders. So if you're using a local version, this is gonna be your C disk, your D disk your hard drive right here. But in online version, these are online servers. So you'll see these files. They are actually stored online, and you can create a folders and put all your files here. And also libraries. This is how you interact with your files. We're going to cover that later. And this is where you work. So you are going to code here. The log, if you execute some codes, the log will be displayed here. And also your results or your data set will be displayed here as well. Okay, so basically these are three main things that you'll be using. Okay, so let's talk about data management in SAS. The first thing is file management. So you can create a folder like for your project, and then you can upload or download files from the folder. So this can be a CSV file, this can be a SAS format dataset file, this can be a SAS code. And also you can create a new SAS program. So by saying SAS program, I mean SAS code. So it will be .SAS. These are executable code in SAS. All right, so let me just demonstrate how to do so. Okay. So let me shut down this. So in order to create a new folder, you can right-click the file home, and then here's a new, and you can create a folder and then name whatever you want. So I just put, say, new, okay, save, and you'll see this empty folder right here. And you can also create a new SAS program. So if you click this, you'll see a new program right here, and you will hit this save, and you can choose where to save this SAS program. So maybe we save it in new, and we just name it program.sas, and you'll be able to code right here. And also you can upload your CSV file or other maybe TXT file. It depends on like what format your data is. So let me just choose files, and then I do have a CSV file called baseball right here, and I hit open and upload. And then you will have this CSV file here. And also, in order to access these files, you have to, in your code, you have to specify where these files are stored. So the way SAS deal with that is called library. So if you hit library and hit my libraries, these are preset libraries. Some are set by me, but these are preset by SAS, like default libraries. So in order to create a library specifying the path, you can use the library to specify the folder from which you want to read or write files, like the CSV file we just uploaded. And if you don't specify the library, the output will always go into the work library. So if you see right here, there's a work library, and the work library is a temporary library. So all data in the work library will be cleared when you shut down the SAS session. Say you closed your browsers, or you just your session is run over time, it will be closed and all the data will be cleared. So in order to create a permanent library, you can use this syntax right here. So the lib name, this is the statement, and this library is the library name you want to name it. So it must start with a letter and contains only 1 to 8 characters, include letters and also digits. And in this quotation mark is the path, the physical location of the library. So it's the folder path. If you're using the online version, it's going to be a online path. But if you're using a local version is going to be the folder path on your hard drive. Okay, so let's just demonstrate how to specify this. So you can use lib name. So this is the statement, and we can name whatever we want. So let's say we name it called new, and then in the quotation mark, I want to put the path of the folder. So in order to get that, I have to right click the folder and hit properties, and you'll see the location right here. And if you highlight it, Control C, and then Control V here. So also in SAS, you have to put a semicolon at the end of every statement. We'll cover that later. And if you run this code, hit this little man, and you'll see the lib name new. So in the log, you'll see the library new was successfully assigned as followed. So now if you hit libraries and my libraries, you'll see a new new library right here. And also you'll notice that in this case, in SAS is actually case insensitive. So no matter it's in uppercase or lowercase, I mean, they're all the same. So yeah. Okay, and the way you specify every like say you want to read a file from this library or you want to write a file to this library folder, the way you specify it is use the folder name and then a dot and whatever files here. So say file, we do have a CSV file called baseball, right? So if it's in a SAS format, you can do baseball and it'll be able to recognize that. But yeah, we'll talk about that later. Okay, so let's see how to import and export CSV files. So SAS have to kind of convert CSV file to a format that SAS can recognize and identify. So we can use SAS Studio interface, or we can use proc import and proc export. So to use SAS interface, you just have to right click this CSV file and hit import data, and it basically just demonstrate the pre-built code right here for you to execute. So you'll see this baseball CSV file where the source location is and the output file. So now you'll see the library is in work. Like I said, this is a temporary library, right? So if you want to change where you want to save, you can just hit change, and maybe we want to store in the same library as the CSV file and hit save. And we can also, yeah. Okay, so after you do so, you can just hit run right here. All right, and you'll see this import.sas7b dat. So this is a SAS dataset format, and you'll be able to double click it and open this this dataset, and all these are in SAS format. All right, and also we can rename it to, let's say, just call it baseball. All right, and now if you have say a SAS format data and you want to export it to be a CSV file, how can you do that? I mean, you can right click it, and then you can use import, sorry. Oh yeah, so we can use SAS code to do so, and I'll demonstrate later. So let me just pull out. right here. Okay. So another way to import CSV file is just to use this proc import statement. So proc import, so proc is stands for procedure. We'll talk about this later. So proc import and the data file, and then you put your file path right here. So in order to get that, it's the same. You just right click it and hit properties, and you'll get the path right here. And in out, you can specify the library of the folder that you want to store this file, and also the name of the data set. So you can name whatever you want, and you want to specify the format of the data that you're going to read in. So it can be a CSV file, it can be an Excel file, or other format. And replace is simply means that if there is a this CSV target CSV file is already, or a target data set file is already exists, you want to replace it with the new file. And get names is to get variable names from the first row. So if in your CSV file, the first row is your variable names, you want to specify get names as yes. Otherwise, it should be a no. Okay, and to export, it's probably the same. So you just use proc export and the data. So this data is in a SAS format, and then you type in out file and specify the folder and also the name of the exported file that you want to name it, and also specifying the format, and also you want to replace it if exists or not, and run. So every proc step or every data step always ends with a run, and you highlight it and you hit this little man right here, and you'll execute that for you. Okay, so let's learn about some basic syntax in SAS. So we talk about data set, and also I want to specify how to name your variables here. So for data set and for variable names, they're all up to 32 bytes in length. So that means 32 characters right there. And you cannot contain any special character and blanks except for the underscore. So I personally use underscore a lot. And it must begins with a letter, no matter uppercase or lowercase, since SAS is case insensitive, or the underscore. So you cannot name a data set or a variable begins with a digit. And it can contain mixed case letters, but like I said, SAS is case insensitive. All right, so next step is statement. So a statement is a series of SAS keywords, SAS names, special characters, and operators that instruct SAS to perform an operation, or that gives information to SAS. So like I said, a statement always ends with a semicolon. So this is different from Python or R. I mean, this is more like a C language. You have to use a semicolon to end every statement. And the variable names are case insensitive. Indentation is not necessary, but we we um, we often do so just for readability, you know. So like for me, I personally put proc import and run in the very left justified, and then put everything in an indent just to for readability. I can easily identify there's a block right here. And also, I always recommend you to use comment. You can use in two types. So asterisk right here at the beginning of the comment, and then a semicolon at the end of a comment. Or you can use slash asterisk and put comment here and asterisk slash. So either way, there are two main steps called data steps and proc steps. So data step is for those steps that you want to manipulate your data. Say you want to moderate modify the values in your data set. You want to create a new data set. You want to create a new variables. You want to merge data set. You'll use data steps. And for other things like you want to do a calculation, you want to import, export data, you want to display like a table or something, you'll use proc or procedure step. All right, so this is the SAS data set, how it looks like. So let me just pull out one data set. So let's say this baseball. So every row is in observation. It'll be labeled 1 to n, and also every column is a variables. Okay, so this is very straightforward. And also in this interface, you can actually, all right, okay, access. Let me, okay, so you can use these arrows to browse the rows, and also you can choose which variables you wanted to display. So there are two main variable types in SAS. So one is character. It can be in numbers or it can be letters. And in order to tell which variable is character and which are numeric, you can look at the data in this data view. And if the letters are left justified, it will be a character. And for numeric, it can only be numbers, including positive, negative sign, decimal point, and also E. And it will always be right justified like this in the data set. And for missing data, if you have missing data in character variable, it will be denoted by blanks. So it just blanks. But if it's numeric data, it will be denoted by a period and just a dot. Okay. Right, so let's talk about data and proc steps. So every steps consists of a group of statements. So it can be only one statement or it can be multiple statements. So like I said, data step is used when you want to create or you want to modify data set or want to merge things of that nature. And the proc step is you want to perform a operation, you want to analyze your data, or you want to present the result. And so common keywords to end the step. So usually we use run. No matter you want to use lowercase, uppercase it's the same. And also quit is used in a run group processing. So there's a function called proc SQL that allows you to use some SQL statement there. And since the SQL statement is run line by line, so you just use quit. You don't have to use run to tell SAS to run all codes. And also maybe you'll see some stop or abort in some situations, but normally we just use run and quit sometimes. Okay. So, okay, data step. So SAS reads data by one observation each time and execute every line of code in the data set, and then it stored it in the output data, and then it reads a next row of observation. So it only sees one observation at a time, except for using retain statement. So this retain statement is going to allows you to retain some variables from say observation 1 to observation 2 to observation 3. But this is more complex. So in most cases, it only sees one observation at a time. Okay, so these are common statements used in data stat. So set means to read observations from the data set. So say we do have this step program right here. So say if I want to create a new data set called new baseball. So first I have to specify where I want to store this data set. So I have this library called stat_byte and dot, and then the data set name. So you can name it whatever you want. And then you want to use set. So after that is the data set you want to kind of like import into your new data set. So I haven't tell you SAS help. So SAS help is a built-in read-only data set. So they provide a lot of data set for you to practice and to manipulate. So you can read data set, you can create a new data set and read from those pre-built data set and practice. And so say I wanted a new baseball data set and I set from a SAS help baseball. And then I can use this where statement. So let's take a look at the baseball data set in SAS help. So in team, you'll see a lot of different teams right there. Yeah, by their city. And say we only care about players who plays in St. Louis. So we want to use where. So it's like a condition. So where team is the variable names equals to, and you if it's a character, you have to use quotation mark to so specify that. And then put is just to put a log, put a kind of like a note in a log, so you'll know what's going on there. So let's run this code right here. Okay, I haven't created this library. Okay, so in online version of SAS, you have to specify, like you have to run this code every time you open the session. So the file will still be there, but you just have to kind of like give it a direction. If you don't want to do so every time, you can use edit auto execute file, and you can put the statement right here, and it will run every time you open this session. Okay, so let's run it again. All right, so you'll see that in this new data set is stored in stat_byte. Let's take a look. So stat_byte. Okay, so here, new baseball data set only contains players play in Team St. Louis. All right, and if you see the log, you'll see how many observations are read from this data set right here. And since we have this statement called put, so every time you're reading a observation that meets the condition, you'll put a note right here. So you'll see 11 notes here. And also another function we use a lot is merge. So merge is to merge multiple data sets side by side. So you can merge data sets side by side, and regardless of any identifier, just without specifying any ID. Or you can, like we often do, is to do match merging. So you have to specify the identifier using by statement and must be sorted first. All right. So let's say we do have two. Okay, so let's create I'll demonstrate that merge later. And to modify, you can use modify statement to modify the values in existing variables and observations. So the benefit is that it doesn't require the data set to be sorted first. And both the master and the transaction data set can have observation with duplicate values of the byte variable. So the identifier don't have to be like unique. And update is to update the data set. So the difference from modify and update is that the data set must be sorted. And in master data set, the byte variable or the identifier must be unique. All right, so let's try to read in some raw data without like CSV file or other files. So you can type raw data directly into SAS dataset, usually used for practice to test out some few data points or to create a transaction dataset. You're not going to like type in millions of observations by hand. And you can use input statement to declare the variable first, and then use data line statement to type in raw data. I'm sorry. And also, if you wanna use in file statement, you can read in an external file, maybe it's in TXT or it's in Excel, but you wanna declare the variables manually, you can use this method. All right, so let's take a look. So for this data set, we create a data set called student. I'm not specifying any library, so it's going to be stored in work library. And I'll type in input, and then I'll type in all these variables that I want. So if you see a dollar sign right here after the variable names, it means it will be a character variables. So the default is a numeric variables, and if you put a dollar sign right here, it's gonna be a character variable. And also you can specify the length of the variables. So let's say for email, I mean, because the default is only 8 character per variable, but for email, I think most of us have more than 8 characters. So you have to specify the length of that variable. And also you can use w.d. It means the width and the number of digits. So for like height in centimeters, maybe you have 4 digits, so it's 4, but you have 1 digit of decimal point, so you'll use 4.1 and you'll read it as 170.1 in these variables. And also you can use @ sign to move the column pointer. Say, all right, so let's just take a look right here. Okay, so let's create a variable from this. So let's run this code. And you'll see your ID, your name, and your email will be stored right here. And your ID is write justified, so this is numeric data. And for your name and your email, it will be character data. And for this, if you run it, okay, so now you'll see you do have 4 digits with 1 decimal digits right here. Okay, and for this pointer, say if you have this ID in the first place, and then you want to move, let's say if they have their first name and their last name, but you only want their last name, right? So you can move your pointer to the fifth position. So this is 1, 2, 3, 4, 5. So 5 is K, right? So start with K, and then you want to read everything else to store it in this name variable, and we can do so. So yeah, so now you only have Kaylee, Michael, David in your data set instead of the whole string right here. So you have to like calculate how many, like which position is this character in. And also you can use this sign to move the line pointer. So when the observation is across multiple rows, you can use this to specify maybe it's on the second row. So you want to read multiple rows into one observation, you can also do so. All right, so also you can use end to end to directly specify the start and end point after the variable names. Say you do have this data files right here. So your height is from 15 position to 17th, and 18, 19th is your weight. So if you don't specify them, they'll read this string of digits as one variable, but you can use this um, pointer to specify them. So now you'll see the height and weight are split, but you just have to calculate that. And also, so let's talk about merge. All right. So for merge, you want to use data. So it's also in the data step, and you want to specify the name of the new data set that you want to merge. And then you use this merge statement, and you put these two statements, these two data set names right there. So we have students, we have student body measurement, and the identifier is this 1, 2, 3 is ID, right? So you have to use by ID and to merge them together. And now you'll see you have 3 rows and 5 columns with their email name and also height and weight. But in some data set, you have to do proc sort before merging. We'll talk about that later. And also in data set, you can use if then condition. So say you have this baseball average data set, and you set from SAS help baseball, and you want to specify you want to find people who have average above 0.3 or things of that nature, then you can do the calculation right here. So if you do a calculation in the data step, you'll create a new variables called AVG, and you'll calculate it by n hits divided by n at bat. And then you can use an if-then statement. So if statement follows by a conditions, and then after then is the action that you want to do. So say if average above 0.3, we want to create a new variable called batting ability, and then we'll set it as strong. Else if average above 0.25, then a moderate. Else is everything else. So if we run this code, okay, so if you scroll it down, you'll see the average is calculated for you, and then the batting ability is classified. Okay, so say if you have multiple actions to do after the if statement, you can use this statement called then do. So if average above 0.3, then do, and you want to put a semicolon right here and put every actions you want with a semicolon at the end. And at the end of these statement, you can use end and put a semicolon. So these are conditions. All right. So you can do multiple actions in a if then do and statement. Also, you do have this do loop. It's just like a for loop. So you can use do I equals n to m by k to set numbers of times of iterations. And also you have to use end to end those actions. Also, you can do while or do until statement to set the conditions. So before the condition is met, the loop will loop forever. So let's say we do have this data called salary we created, and we set the bonus rate equals to 0. And now we want to do I equals 0 to I equals to 10. And we want to increase our bonus rate by 0.1 every loop. And if we run it, okay, so you'll see the bonus rate become 1.1 and I becomes 11. So because you do I equals 0 to 11, sorry, to 10, but it will run the last loop again, so it will become 11 and 1.1. And also you can do until. So maybe you have mortgage for $1 million and now your payment is 0. You want to do until your mortgage becomes 0 and pay $1,000 every payment, and you can run it. And you'll see your mortgage becomes 0 and you do have 1,000 payments there. But we don't usually like do this a lot in SAS. All right. So in format and format, this is how you tell SAS to read in your data in a non-standard format. So maybe say date, dollars, or things of that nature. So in order to specify them, you want to use a called the for example, for date, you have MMDDYY10 dot. So these means you have 10 digits and the first two is MM and then DD and YY and you have slash in it. And this allows SAS to understand or identify the format of this data. And we also have a lot of functions right there. Say you want to round a number, or you want to take the ceiling or floor, or if you have a date format data, you can use year or month or day to extract those year, month, date from that format. And also you can use cat, so to put things together and create new variables, things of that nature. All right, so I want to talk about proc steps real quick. So procedure is how you print out data and check the content, and like make a table to calculate mean, median, or things of that nature. And proc print is probably the most used to kind of see what's in your data. So you can use proc print and specify which data. And if you want to just look at the first time observation, you can do so. And you want to use var for variable to see which variable you want to display. And also, if you use proc contents, it will provide a more detailed information for your data set, say the data type or the length of the variables or something like that. And also, I often use proc freq. So proc freq is to create a frequency table for certain variables, and use you can use byte statement to separate subgroups. So say by gender, and you'll separate subgroups for male and females to create separate tables, and use this table statement to specify the variables in interest and to put space between each statement for a one-way variable. And if you want to create a two-way or n-way frequency table, you can use a asterisk symbol between those variables. And also you can use slash to indicate some options. Say you don't want cumulative percentage, or you don't want rows total or something like that. And also the last thing I want to specify is that sometimes when you want to merge data together, if the ID is not in order, you have to sort them first. So you want to also, if you want to use, say, proc freq with a byte statement, so you want to by gender, you want to separate males from females, you have to use sort first. So in order to do so, you can use proc sort and the data you want to sort, and then out means the data set you want to store, or you can just, if you don't use this, you just sort this data and you can use by statement. So this is the identifier or the variables you want to sort. All right, so I want to leave some time for you for any questions, but these are some useful functions. I'll put this right there for you, and I'll upload this slide for you to see. So say there are a bunch of different um, functions for you to use, like proc ANOVA, proc reg. This is for regression, logistic regression, something like that. But today we just don't have time to do so together. Yeah, so I'll put the slide for you to play with, and let's see. Okay.
Can everybody join me in thanking Yuku for a great introduction to SAS? Um, yeah, getting some claps and thank yous in the chat. We will have his Yuku's video uploaded to the Inside Brown Stat Lab page, and we will put the slides with the videos so that you can access everything there. And I think we have 2 or 3 minutes for questions if anybody wants to stick around for a couple more minutes.